Okay, welcome back. Let's hope for a slightly more productive session this time. Last time around, I sat down to do the piece rotation stuff. And if I'm honest, I think I was slightly sleep deprived and struggling to actually get anything done. But we did get something done. I think we got half the problem solved. So, let me go ahead. Oops, wrong buttons. I don't know how you do it. There you go. We go run the program. We've got the piece rotating about a kind of ill-defined point, but we've not solved our bounding box issue. So you can get weird stuff like this where I'm hitting left, it can't move left because I've not properly updated my position to reflect the rotated state of things, if that makes sense. So the next thing to do is to fix that. Now, I think maybe I'll draw a bit of a picture. Honestly, I think I might have even mentioned in that other video, it's been quite a while since I've had to think through sort of rotations and anything like that, but I have got a bit of a mathsy background, so I'm hoping this is all kind of within my power. So if we think, what we've got is a bounding box that's defined, and we're going to have some point we're rotating about. And the coordinates of that point are given relative to the position of our box, right? So if our origin's back over here, we've got a position here, which we'll call P, which is the XY, XP and YP, that describes the position of the bounding box. We've got the width and height available to us. And then we've got the point that we're going to be rotating about here, which we're going to call R. Let's call these XR and YR, right? And that's kind of the set of inputs we currently have. Whether they're the best things to have used, I don't know, but that's what we've currently got in our data model / what I'm planning to add with this R. So when you've got the piece that you're drawing in our editor that's to come, you'll have a 5x5 grid, you'll draw in what you want, you'll put your R in, we'll work out what the bounding box is, and we'll be able to say where the point of rotation is relative to that bottom left corner. And the question is, what should happen to the position of this point on a rotation 90 degrees in either direction? Now, I've not thought this through all the way, but I think one thing to say is rotations are really simple about the origin, right? So a rotation around 0, 0 is just a simple matrix transform, right? So I think what we do is, I guess step one is we translate, say by minus p, right? We add minus p to all our points. And that, no, not true, to minus p plus r. Right, we move the rotation point to be at the origin. So then we're into like rotation matrix world. We rotate, and then we translate back. I think that should work. That rotation point, I don't think should be too hard, because we're not doing generic rotations, so we don't have to worry about like what happens if I rotate by an angle theta, and how do I lock that like to the grid in some sensible way. We're only going to rotate 90 degrees in either direction. I don't know how familiar like most people are with matrix rotation, so we'll run through it quickly. If I have what you'd call a basis, so we're in 2 dimensions, it means that all of my points can be described by combinations of these 2 vectors. So we'll call this our basis. More specifically, it's an orthonormal basis. So it's 2 vectors. It's normal because they're both of length 1, right? And they're orthogonal because they're in completely different directions. So moving along one does not move you along the other. And you can describe a rotation, or you can describe any linear transform of like the space that this basis describes by just writing down where this basis vector goes and where this basis vector goes. Right, and that's how you get your transformation matrix. So if we consider here, we have, so this is 1, 0, this is 0, 1. And if we do a 90 degrees rotation, let's do, I guess, clockwise first. So we go clockwise. Then, I guess we'll call that one there y, and we'll call this one here x. Then y goes to where x used to be. Right, so this here will be y prime, and this here will be x prime. Right, and so the way we get our rotation matrix is we'd look and say, okay, so x goes to x prime. So instead of being 1, 0, it's now at 0, minus 1. Right, it's pointing down. And y goes to y prime. Well, y is now at 1, 0. Right? And you can see, so if I multiplied that by 1, 0, I get 0 times 0 plus, what would be a cross by down, so plus 1 times 0 gives me 0, minus 1 times 1 plus 0 times 0 gives me minus 1. Right, so 1, 0 would map to here. Right, and similarly, you can solve yourself for 0, 1. So that's the bit we want. And similarly, we did the, I guess, anti-clockwise. Y would now be pointing to the left. Right, with y prime, x now points up. So x goes to 0, 1. And y goes to minus 1. Easy. So because we're only interested in those limited cases, that makes our life simple. So I think we're going to just hard code those in separately. I guess the interesting thing is if we consider we're not interested in where this bottom corner goes, right? Because if you think, if I've got a bounding box that looks like that, and I rotate it about some point by 90 degrees, if I go this direction, or actually interestingly that direction, it'll flip it over. And really, this corner A will map to this corner A prime. If I go, which way would that be? If I go clockwise, and this corner B will map to this corner B prime. So because we're describing the position of the whole box by its bottom left corner, we're actually interested in where this corner goes when we rotate clockwise and where this other corner goes when we rotate counterclockwise. Which is all to say it's slightly messy, but no one bit of it's too tricky. So I guess there's a step 0 here, which is to sort of pick the point we care about. Because it depends on what rotation we were doing. And I think that's all we need, right? And I think that would give us enough to say, not just where did the filled... sorry, I'm explaining this poorly. We've already got it describing where the filled array looks like after the rotation. This gives us enough to say where does the position change to. And hopefully that all behaves like we expect. I can't remember where this lived though, so let's see. It's probably in game. Of concerning looking warnings. There we go. So this is where I think I got to before, I don't know, my brain just stopped working. So what did we do? We're saying rotate active piece. Do this. And then we update its filled. So we now have what the piece should look like How do we do this then? So we've got updated piece. I guess we're going to want something like updated position. Will be a grid pos. And again, I think we might switch direction. Go case clockwise. Does one thing. Case anti-clockwise does the other thing. Both of these should set updated position, basically. And we get down here, and if collision detection passes, we update our active piece position to be updated position. That makes sense. That sounds good. Right. So if we're rotating clockwise, then this is the case where we care about where the point that's currently at position plus width maps to. So how do we say this then? So it's something like bottom right. So the initial bottom right position is equal to our game state active piece position plus our nope, it's plus the current one. So game state active piece bounding dim dot width. I guess it's where the bottom right point is. I've got no way of adding positions, have I? So we're going to do this in the dumb and ugly way. So bottom right position will be x active piece position dot x plus that y is active piece position dot y. Right. So given a point, we've not got anything to represent our rotation point yet. Yeah, I've got my point x that I care about. We've got we'll find where r is equal to. Which is at xp plus xr and y plus yr. X is going to be equal to xp plus width plus yp. We want to translate that, right? So step one, we translate it so we get our translated x, which will be at x minus xp minus xr, and at y minus yp plus yr, so yp minus yr. We substitute this value here in, then the xp's will cancel, and we get left with w minus xr, right? And in the y direction, the yp's cancel, we get left with just minus yr. In step 2, we will do the rotation. Which one of these are we doing? We're currently doing clockwise, which is this one here, 0, -1, 1, 0. So it's 0, -1, 1, 0 times w minus xr and minus yr. So 0 -1, yeah, you go across by down, gets you 0. Alright, because that's 0. No, lies. So 0 times this is 0, plus 1 times this is -1. So you get minus yr. minus 1 times this is xr minus w, and 0 times this is 0, so we get that. And then we translate back, so we get back to x prime prime prime, which will be equal to x prime prime, and where this one was minus those values, it'll be plus, I don't know, the position of xr. Sorry, I'm mixing my notation now. Which is to say it's at minus yr and xr minus w, and we will go to that plus xp plus xr, yp plus yr, which is equal to xp plus xr minus yr. Interesting, the width has just dropped out. Oh, the width's in the y direction. That's fine then. And then this one goes to nothing about xp, which is interesting. Yp plus xr minus width. Xr plus yr minus width. Now, I don't know for sure that's right, but if we do it and it looks right, then we'll know. So we get the bottom right position. That's the position we care about translating. Can I actually move you to here so I can see both at once? I regret having messy handwriting, but I think that's still readable. Right. So if that's our bottom right position, which is our x, essentially, it's the point we're going to translate, then updated position can be equal to x equals bot right position dot x, that's xp, plus xr. We don't have anything for xr yet, which was a mistake. So let's go ahead and put that on piece. I can't remember where piece lives. Something in here must use the type piece. There we go. So we get the rotation point, or rotation center. Not be a grid dim, it can be a grid pos. Right. Pop you there. That's going to be our xr, yr. It's the displacement from the bottom left of the point we're going to be rotating about. God damn it, where have I put my things? So updated piece dot filled. Get this thing. There we go. So updated position will be bot right pos.x plus game state active piece rot center x minus game state dot active piece dot rot center dot y, and the y coordinate will be at bot right pos. No, yes, bot right pos is our like xp yp plus game state active piece dot rot center. It's concerning that our rot center x appears in this. Maybe game state active piece dot rot center dot y minus r active piece dot bounding dim dot width. How does that look? So if we go and run that, and we will see if we can rotate clockwise and it makes sense. Ah, okay, it does not make sense. That's pretty funny. Okay. What did we mess up? Well, clearly something's gone wrong in here. My logic about translating wrong. Because it looked like it's rotating it not about the point I'm expecting. We add a bit of logging in, see what it's actually getting out. So if we look in here, we'll go format, print line. Old X is hot right pos dot X. Oh, just put them on separate lines just so it's easy to turn individual bits on and off. Hot right pos Y. New X, oops, is dated position X, and new Y is updated position dot Y. Alright, let's run that again and see what numbers are coming out. Where it thinks we're ending up. Ooh. Why aren't we printing anything? Why, stupid. We're rotating clockwise. Ah, to be fair, actually. No, so our rotation point's being set to 0, 0. Shouldn't do anything too weird, right? Because it's 0, 0, meaning just like we're going to rotate about the bottom left point of our shape. Although, I think I've got my rot center wrong, haven't I? Because the XR is relative to the bottom left, which is not actually the point that I'm rotating. Yeah, I think I fucked this, haven't I? I wonder why it's not printing anything. It is saved. And it's very clearly doing some of that logic, isn't it? Am I just doing something really stupid? So rotate active piece. I format print line in here. Rotate active piece. I'm in here. Yeah, so we are getting there. Switch on direction to do this stuff. Switch on direction. Yeah, we're not getting to clockwise. Why is that? We're not in here, are we? Oh, so we are. Am I stupid? We're in here. Rotate active piece is called where? In here. you press S, I'm going the wrong way. I am stupid. Oh no. Okay, let's try again. Ooh. Interesting. Let's put you over there. No, that doesn't look right, does it? It's rotating about its bottom left. That doesn't look right at all. Right, let me go ahead and do just one and just see what the numbers are coming out like. So we bump ourselves back up, we do one of these, and we exit. So our bottom right used to be at X equal to 5, Y equal 15, and it's going to X is 5, Y is 10, which isn't terribly wrong, right? Because we expect it to kind of move down. Okay, hang on. So let me go. Help to make our shape smaller and kind of easier to look at. Maybe. Tidy up some of that because we don't need all of these now. All right. So what are we doing? We currently have a single hard-coded piece. Don't know where that piece is defined. Not defined there. Width piece height. Active piece. Is equal to piece. There we go. So this is defined from the bottom left. So if I make it go 1, 2, 3 across, and then make both of these false. Do this. Get away. Rest. We'll leave that one as is, and I guess this one will make the middle one false. So the shape is less symmetric and we can see rotations more easily. So it's dropping there. And then that looks super stupid because we did it too near the thing. But so if we rotated it there and it went around its bottom left, I don't think it ends up where it ends up, but we're not that far off, are we? New X, new Y, old X, old Y, new X, new Y. Okay, do we check our maths? I think maybe I do the maths again and check that I get the same answer. And if I do, I think we do the expected numbers if we do it at like 0, 10. And then we'll step through the code and see. Right. So we have got our origin, got our box. So this here is the point. Just call it P. This we're calling width. And we've got a rotation point. That is R. Where P is equal to XP and YP. R is equal to XP plus XR. And YRP plus YR. It's defined relative to that point. Our rotation point needs to change when we've done that. That's something I've not thought about. And the point we're interested in is this point A. A is at XP plus width. and yp. Right. So the first step is we translate a so that we could get r to the origin. So a prime is going to be equal to xp plus w minus xp minus xr. Right, so we're translating that to 0. And yp minus yp minus yr. Oh no, I'm out of space. Oh, I'm not familiar enough with this to know if I can just like drag a box and make a thing smaller. Oh no, I'm getting shown up. How do I like, I can zoom in. Can we just zoom in and write it smaller? Right. Part 2. A prime prime is this multiplied by our rotation matrix, which thinking would be 0 minus 1 1 0 multiplied by xp plus w minus xp. Okay, so first thing to say is that xp and that xp cancel, that yp and that yp cancel. So this is actually equal to a simpler expression, w minus xr and minus yr. So that is equal to 0 times that doesn't matter. That one gives us minus yr. Minus 1 times that gives us xr minus w. 0 times that gives us nothing. Right, across by down, across by down. And then we want to translate back. So part 3 is that a prime 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 is equal to, everything gets shifted. So we have minus yr plus xp plus xr. And we have xr minus w plus yp plus yr. Is that the same thing we got the first time we worked it out? Zoom it out, zoom, zoom, zoom. Minus yr plus xp plus xr. xr minus w plus yp plus yr. Okay. So if... So it's not an arithmetic mistake or an algebra mistake unless I've done the same mistake twice, which is possible. So either our actual like reasoning is wrong or our implementation is wrong. Right, let's pull that back in here then. Let's go find where we were doing all of that. I'm already in game. I'm treating that as being XP, aren't I? Which isn't right. Right. I think I've royally fucked it. Let's do it again, because I think it's our implementation is just bad. So, if we do this one, I think the updated position should be equal to grid pos. Our x should be at xp, which is the game state active piece position dot x plus game state dot active piece dot rot center dot x minus game state dot active piece dot rot center dot y. All right, so it's xp plus xr minus yr, and y should be equal to, make sure I'm looking at the right thing, So that was XP plus XR minus YR. Should be active piece position dot Y, YP, plus active piece, nope, plus active piece dot rot center dot X plus active piece dot rot center dot Y minus game state active piece dot bounding dim dot width. So we just one shot it. Was that our problem? So if we come up to here, yeah, nice. Index -6 is out of range. So we aren't updating the rot position, are we? Right, because where the bottom left has moved. So we need to update that so the next rotation can be done correctly. Which... Jesus Christ, how do you work that out? I mean, it's the same transform, right? It's just that instead of XP plus W, you're XP plus R. Can I just replace that W? Yeah, sorry, I think I need a wee. Stop me thinking. I'll be 1 minute. Okay. To explain what I'm thinking, so I don't think I've done a very good job of explaining it. Oh, is it not easy to... How do I just say I want another sheet? Page preview. There we go. So before we've rotated, we've got that's our position. We have some R point in here. We've done our rotation. Everything is moved except that R, right? But we now need to work out what that R there is. It's not necessarily the same, right? We're talking about the same point in the grid, but it's got a different displacement from the bottom right. That's XP and that's XP prime. We know that the actual point of rotation doesn't move, right? 'Cause that's the kind of definition of the center of rotation. So we know that XP plus R is equal to XP prime plus R prime. What does that mean? We just do R prime equals XP plus R minus our new one. What does that look like? XP plus XR minus XP prime, YP plus YR minus YP prime. I think that should work. We now have all of those values, so I think we can say in here, once we've got the updated position, get updated rot center is equal to another grid pos X is equal to game state active piece. Click on it. Do it. It's GC, not GS. Okay. GameState.active. There we go. Active piece position.x. Last game state active piece.rot center.x minus updated position .x, and y is game state active position.y plus active piece rot center.y minus the updated position.y. And when we get to the end, we do the rest of these. We have to say, can we just put that straight on updated piece? So we don't need this because we've already got a place to put it. We'll go updated piece dot rot center equals that. Right, so if we're going to keep updated position, we're going to keep this updated rot center. Right. We format print line. In fact, it should be kind of obvious if that worked, right? So I should be able to do 2 rotations and have them actually look reasonable. So if we're up in this corner, that looked reasonable. We do it again, and again, and again, and again, and again. You can see it kind of pivoting around. That point. And then, yeah, we've not done any checking to make sure you stay in the grid, so eventually you crash. I think it's worth us printing some values just to check. We're going to have old x. I kind of want to check explicitly that things are looking right. So old x will be equal to game state active piece position x, format print line. New x is game state active piece position y, print line. Sorry, that's old y. That. And I go ahead and do yoink and paste and line it up. And new. Idiot. Updated position. Updated position. And we keep all the old values together. So I'll say in here, old rot center, game state active piece dot rot center. Down here we'll have format print line, new rot center, game state active piece dot rot center. Start. Get it in the middle. Bang, 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 bang. Right. You can tell it's sensible if you always find that basically this value plus this value and this value plus this value get in the same place. So if the old xy is 513, the rot center was 0, 0, then our new values, that can't be right. Can it? Because then the rot point has moved. Piss. We are seeing this number change though. Okay, let's do a single rotation, so we get just one of these. Right, so we put ourselves somewhere where it fits. That should fit if I do it there, right? So we were at 0, 15. Our rot center was 0, 0. We do the rotation, and our rot center is moved by 5. Can that be correct? I don't think that can be correct, can it? So I guess to be clear, what I'm thinking of, so this is XP and YP, and this is the original XR, YR. This is kind of XP prime, YP prime. This is XR prime, YR prime. If our rotation has worked properly, then the sum of these and the sum of these should be equal, because the point you're rotating about shouldn't have moved. See here, they're clearly not. But why? I guess the first thing to say is typo checks. Game state active piece position dot y plus game state active piece dot rot center dot y minus updated position dot y looks correct. That looks correct. I'm so confused. Currently, just the Y one is going wrong. That's just a happy coincidence because we rotated about x equals 0. Put x equal to like 5, do a rotation. Okay, yeah, it's because that is 0. We don't expect it to be moving. I'm only confused because it also looks like it's doing what we want, though. That's the thing. Written the right thing in new rot center? I'm not. That's my problem. That is updated piece. Rot center. It goes from 3.9 to 3.9. Yeah, okay, it is doing what I want. Jesus Christ. Why is it always the dumbest thing? Every time. But that's good news. And we can kind of see it looks as expected. Right, if I come in here and I just mash this, it kind of does look like I want it to, right? It just spins around that point in the bottom left. Slightly tricky to really say because piece obviously is dropping. If we take it there, we keep resetting ourselves. Right, it gets back to where it started. Cool. So work's not done because we still need to do anti-clockwise and we need to do collision detection. But that seems like good progress. Now, I think the updated piece rot center is actually the same for both cases. I think we can pull that out and do it here. Means this bit is just updated position equals a grid pos. And we just need to work out what the equivalent formula is. Right? A sip of tea. It's really surprising how it's one of those things. I think until you record yourself and listen to yourself speaking for a long time, you don't realize all the weird things you do. And one thing I didn't realize is how fucking croaky I get. I think maybe it's down to like not projecting your voice properly, right? It's one of those if you worked in a job where you were shouting all day, you'd get good at it, but not me. Yeah, I think we just need to do a bit of maths to work this next one out. This is obviously the downside to treating it as two separate cases, right? Is that if we just did a thing that worked for any angle, we would now just feed in the different angle. But hey, is what it is. So let's move. Whoopsie daisy. I'm on the wrong screen. That's why. You to another screen so we have a bit more room. Want to basically do this same calculation, but we want to do it down here. So in this case here, we're going anti-clockwise. It's the same setup. So we have our origin, we have a point P, have some rotation point R. We've not checked that a non-zero zero rotation point works, but let's do that after. P is defined as xp y. P R is defined as xp plus xr y plus yr. Anything else to say? This value we're calling height h, which is going to be relevant to us this time. And we would like to transform point A. A is equal to xp yp plus h. So step one is translate so that our center of rotation is at 0, 0, which will get us to A prime, which will be at the point xp minus xr. Let's do it stacked. And yp plus h minus yp minus y. My god. R. See how mistakes happen, can't you? These cancel. These cancel. You get left with minus xr and h minus yr. Which hopefully looks similar to what we had up here, but kind of flipped, right? Instead of a width in this one, we now have a height in this one. Because we're rotating about, or we're looking at a different point. Right. We want to do our rotation, which will involve a different rotation matrix. So again, we think about our little picture with x and y. We're going that way. So x goes from being in this direction to being up. So it's 0, 1. And up goes to the left, which is minus 1, 0. Minus xr. We have h minus yr. Do a cross by down. So 0 times that is 0. Minus 1 times that gives me yr minus h minus xr. And then we want to translate back a triple prime. So we get ourselves yr minus h plus xp plus xr. And we get minus xr plus xp plus xr. Interesting, those xr's cancel. So where do we end up? We end up at yr minus h plus xp plus xr. Our y is just xp. That seems slightly hard to imagine. So our y position is guaranteed to just end up being that original x position. Well, that depends on where our rotation point is. Does it look like this does? I got a sign wrong somewhere and something cancelling that shouldn't. Yep, I have. These shouldn't be x's, should they? So let's rewind. Back, let's just do that step again. I don't like the risk of ruining everything because of bad maths. One of those problems, I think, when you do more and more difficult maths, it ends up having more and more steps. This is all relatively straightforward maths. You end up doing like big, I don't know, integrals or partial differential equations and stuff. The amount of times that you've done something actually quite complicated and the end answer is wrong and you have to trace back through page after page of arithmetic to just find like the dumb thing where you got a sign wrong or you cancelled 2 letters because your handwriting was too messy is just soul destroying. Right. Where are we then? So yr minus h plus xp plus xr. Right, we're undoing this step, which means I was doing x's here, they should be y's. We have ourselves then minus xr plus yp plus, I've done it again, yr. And then just rearrange it because I don't like having it start with the minus. I'm going to put xp plus xr first, plus yr minus h, and yp plus yr minus xr, which is broadly comparable to the other thing, but with the kind of like extra term on the opposite side, which makes sense, kind of feels right. So let's go ahead and write that in. Hopefully we've solved all of the tricky bits. This should just work. So xp is active piece position dot x plus xr active piece dot rot center dot x plus active piece rot center game state active piece rot center dot y minus game state active piece bounding dim dot h, and y is equal to game state active piece dot pos. Oh, it's not dot. Position dot y plus active piece rot center dot y minus game state active piece rot center dot x. Format it, save it, run it, rotate one way, rotate the other. That looks pretty good to me. That's pretty fun. So this now lets you get into a state where you're hanging over the edge and then a move down will break. Although we are breaking our bounding box. That's slightly upsetting. How are we doing that? So we rotate the active piece. We're swapping the bounding dim. Feels like it should just be correct, right? Updated position, grid pos, x equals all this, y equals all that. We update the rotation center. There's one thing to say. We expect these two to be kind of inverses of each other, right? So if I come in here, if I do one then the other, right, so we're currently in a good state. If I go bang bang, we're back in a good state. If I do this, we're in a bad state. If I go bang bang, we're in the same bad state. If I do 1, 2, 3, 4, I'm in the same bad state. Sorry, it's not clear. I'm hitting left, and it's not moving me left any further. And if I go right, it lets me off the edge. So our bounding box is in the wrong place. And that makes sense. Because we're not doing anything clever when we do that rotation. Okay, so it's our filling in logic isn't smart enough. Right, when we update our filled, we're just dumbly saying, so we've got a 5x5. Right, so how many's 5? I need to draw 4 lines. And 1, 2, 3, 4. And we start in a state that makes sense, like this. Right, and we say this is our position, this is our bounding box. We rotate it anti-clockwise, and what we're currently doing is we're going along, so our thing is ordered going that way and then that way. And we're just copying in a way that maps the entire 5x5. Draw another box. We are copying the entire 5x5, so we go this one, when we go anti-clockwise, is mapped to this one, right? And then this one, when we go anti-clockwise, is mapped to this one. When we get through to the end, our thing looks like this, and we're calling that the bottom left of our bounding box, which is really stupid. So I think what we actually need to do is make our filled logic not buggy, because that's really silly. How do we do that? So I guess we know the bounding dimensions up front. So I guess what we have to do is we need to say, I don't know, make it magenta. We know that everything that's going to be filled will fit inside that bounding dimension, which means we know everything that's going to be filled will fit inside that section there. So we need to assign everything empty and then do our filling logic as it currently exists within the bounding box, not within the whole piece. My god, this was meant to be easy. You ever start on something and then think, like, this can't actually be as complicated as I'm making it? Also, if anyone's watching this and thinking, like, the way this is all written is kind of gross, it'd be nice to come through and do some tidying with different functions for adding grid positions and stuff, I agree with you, but I want to solve the actual problem before I worry about making it neat. I think actually if you look through the code base, it is full of grossness at the minute. But I'm reticent to start messing with it too much. Because... just kind of because. Right. Okay. Let's come up here then. That gives us another to do, which is that our filled logic in here fix bug. So what is that to say? Rotations can leave bounding box displaced from bottom left. If not 5x5. So if it's a 5x5 shape, it ends up fine. But I should be able to see that actually if I take. So I've seen it while I'm doing rotations anti-clockwise. But if I do 1, 2, 3, yeah. So if I go clockwise by 3, that's actually a good sign. Our logic. If I go 1, 2, 3, and it's disjoint, and then if I come back 1, 2, 3, you can see it ends up back in the same place. I think it's hard because everything keeps jumping around. Okay, I'm pretty sure I know what's going on. So that bug needs fixing. And we still need to add collision detection. So when we get our updated position we want to go to, we need to check that it's a valid position before we do it, because otherwise you can get into weird states. But that said, I'm going to do a quick little checkpoint commit. And then I want to go and check that if I add a non-zero rot center, that things still work. Let's go ahead and say work in progress. Toward piece rotation. Oh, I've got other stuff unmerged. Okay, my stuff from the last session I haven't pushed up yet. I was too ashamed. Actually, to be honest, I think I didn't push them up because I had a half thought that that hour was kind of embarrassing. I didn't get very much done. I guess I think I was just too tired. You know what it's like. Life gets busy. I've been really struggling to fit this in. I think I'd been struggling to sleep that night, so I was like, fuck it, I'm just going to do a session and get back into it. And I think it was probably a bad choice. But I did make some progress, and I don't know, this meant, in my head, I think if this is useful to anybody, it's kind of as a little diary of what it's like to go and build a thing from scratch. Like, I'm a like day job web dev. I write stuff for a living, but I don't know. It's very different than writing this, right? This is much more nitty gritty in the details. A lot of the stuff we do is kind of like we have a tool, it outputs this huge blob of JSON. We have a big library that parses that JSON and gives you all the numbers out that you need, and then you're wiring things together at quite a high level. This feels like a very different muscle to flex, which is probably why I'm not particularly great at it. But hey, this is how you learn, and I guess if this is, it's not going to be useful from a kind of like learn from an expert perspective because I'm not an expert. Maybe it's useful to other people in a like you could do it too kind of sense, right? You don't actually have to be any sort of expert to work these things out. But now I'm just waffling. I'm putting it off. What am I doing? I want to go and set a non-zero-zero rot center on my piece, which I think is yeah. Right, so we get to the end of all the filled. Has some bounding dims that are just hard-coded for now, and we're going to add a rot center, which is currently 0, 0. We're going to make it 1, 2. Okay, I need to think. So what does 1, 2 mean? It means it's rotating about that point. That doesn't look right. Right, it shouldn't be jumping like that, right? The 1, 2, I think, is this point here. We expect to be kind of like pivoting around the corner onto that. Well, maybe it is doing that, and I'm just... No, it's jumping to the left, isn't it? That looks right, doesn't it? 1, 2. I mean, if one way looks right and the other way undoes it, I might have to just do something that draws in a point on the rot center to make it easy to debug. I don't even know if that makes sense. How embarrassing. Should I have kept that printing in? Because that actually is kind of useful to see. So format print line. They say old pos is what game state active piece position format print line old rot is game state active piece dot rot center format print line new pos game state active piece position and format print line new rot is game state active piece. Game state dot active piece. I think I know what it's doing. It's the same bounding box issue. I'm willing to bet. Dot rot. So I think these numbers are going to look sensible, but they translate to something that's nonsense because the bounding box is wrong. You know what might be more useful is if I comment that out. I instead say assert that old GS active piece position dot x plus game state active piece dot rot center dot x should be equal to updated piece updated position plus updated piece rot center x, and similarly for y. Right, if I come in here, query replace dot x with dot y. Go yes, 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 yes. Comment for future me. Rotation center should not be displaced by the rotation. Is to say, I don't think we need all of that, because I think this does the same check that I was about to do manually. And if I mash the buttons and it doesn't blow up, right, so it is doing what we thought it was going to be doing. It's just that some of these jumps look wrong, but I think it's looking wrong because the bounding box is in the wrong place. Right, it's doing maths that makes sense. It's just that our object we're doing it on doesn't make sense. Cool, that's useful. I'll leave that in there. Okay, how do we fix this bug? Rotations can leave the bounding box displaced from the bottom left if not 5x5. Get clockwise rotated filled and get anti-clockwise rotated filled. Currently just takes the filled. I think it's going to have to take... I mean, should it just take the whole piece? Because it needs the bounding dims, and that's on the piece. Instead of that, we're going to take in a piece of type piece. We're going to output the new filled. Ah, okay. That's kind of nice. It means that our piece width, piece height assertion might not be needed. Okay, how do we do this then? So output is 0 initialized, so everything is currently false. Do I just delete this? And make a list that explicitly goes over the... Alright, let's delete that and think it through again. So, for piece.boundingDim, I'm going to use I for my X position in the input, like that. Use J for our position in the input, up and down. Actually, that's not allowed. Cannot assign GS. Oh, okay, the other one's bad. Because they're not X and Y, they're W and H, because they're dims, not positions. Right. Fix the other one afterwards, because it's going to have the same kind of issue. In fact, I want to do this the other way around. So this takes us across and then up. And that needs to map. In a way that I've not quite got my head around. So our bounding dims are guaranteed to be less than or equal to piece width, or to be strictly less than piece width and piece height. which one of these? We go clockwise. So yeah, this is that same kind of thinking we had before, right? About how if I've got inputs, but it looks different now because I've got, let's go, insert another page. So let's have a think. So I've got my 5x5. Inside of my 5x5, I have my bounding dimensions. And I'm rotating clockwise. Gets me my new 5x5. My bounding dimensions are still going to be in this bottom corner. They were by chance before because I filled the thing horizontally. So that's probably the issue. These, if I talk about them in terms of ij coordinates, they go from 1, 1. Nope, sorry, if you don't count from 1. They go from 0, 0, 1, 0, 0, 1, 1, 1, 0, 2, 1, 2. And when I map them across to here, 0, 0 wants to go into there, and 1, 0 wants to go into here, right? 0, 1 wants to go here, 0, 2 wants to go here, 1, 1, 1, 2. So what does that mean? So I need to remember the stride in my buffer is actually the piece width, right? Not the bounding dimension. So assumes 0 initialized equals empty. That's not always going to be true. We have our j and I, and what we want to say is as we increment up I, we're filling columns. So say here out col index, right col index. And it counts up from left to right. So that's to say, whatever j is here is, so the fact that j is 0 for these two is the reason why the x here is 0, right? They're in the 0 column. So here, j is 1, and in here they go 0, 1. They all get written into there. I think that's true everywhere. Then, within each column, let's say our right index. Is it just I? It can't be that simple, can it? So, it's not that simple. Okay. So, 0, 0 goes to 1. 1, 0 goes to 0. So, what it is we're going to our... Oh, my God. So, we have that this is the piece height. That is the piece width. We are going to this coordinate because it's at piece height minus the bounding box width, which is 2, which will put us at 0, 1, 2, 3, minus 1, because these things aren't inclusive. that right? This thing's width is 2. You have 5, but really it's 4 because we're doing 0 indexed. Is that how you get it? If I put in I equals 0, which would give me then 5. Right, so that's 5. Width is 2. Right, that makes sense, right? Because it's this dimension is what affects this dimension here. It gets me 3. Minus 2 gets me to 1. That gets me 1. When I equals 1, it gets me 0. Which makes sense, right? Because this point here goes to a y value of 1, and this point here goes to a y value of 0. So our row index here is 1, our row index here is 0. So our right row index is going to be equal to piece height minus piece dot bounding dim dot width minus 2 plus I minus I. Minus I because it's going downwards. What's wrong with you? Cannot assign the value to that right row index is never used. Fine by me. Because we're about to use it. Which means then output at right col index plus right row index times that stride, which is piece width, is equal to what's our val? We have I and j. We need to take our input, so it'll be piece dot filled. I is our column index, so we go I into it plus j times piece width because that's our stride. That sound about right. Let me just try it and see. Need a similar change here, so we'll have a piece and an output. And we're going to sack off all this. Going to have that same, assumes 0 initialized. Output equals empty. So again, that's true currently while it's a ball. It's possibly not true when that struct gets more complicated. We're going to want a very similar loop, but the places that it goes to will be different, right? So we'll have dim h. Naught less than piece, bounding dim width. The val will be the same. So we're looking at the input in the same way, we're just going to map to a different place in the output. Right. Which means we're going to have to think about right col index up here. We're going to need to think about our right row index down here. And then we're going to use them to say output at right col plus right row index times stride is equal to that. Right. So if we think about the opposite case, got our 5x5. Going to go anti-clockwise this time. Again, we've got our bounding box. It's going to go to another bounding box. Again, looks the same. But our mapping is different. So, looking at it in terms of ij, where I counts left to right. So we go 0, 0, 1, 0, 2, 0, 0, 1, 1, 1, 2, 1. Just double check it's the same as I've done up here, but oh, okay, I've done the opposite way around. This maps to, so 0, 0 is going to go to this corner here. 0, 1 goes in this corner here. 1, 1 and 2, 1 look like that. 1, 0 and 2, 0 look like that. Right, that's what anti-clockwise rotation would map like. Again, we have our piece width, our piece height. How do we work out our values? So J tells us again which column we're in, but this time it's flipped. Right? So why is it a 1 that maps to 0? Why is it a 1 that maps to 0? Is it going to be piece width minus the bounding box height? It's the input's height that determines this. Right, if this were taller, then this would start at a different value. I think, again, minus 2 to deal with the fact it's all... whatchamacallit? And I think it'll be minus j, like the last one was minus I. If j is equal to 0, that's 5, the height is 2. That gives us 1, and j equals 1, give us 0. Right? And if we look here, this is my j equals 0, 0, 0, and it does go into j equals 1 over here. This is my j equals 1. Sorry, I'm saying j like that's confusing. It goes into the second column. Like you see, these all have 0. These all have 1, which is in the 0th column. I think that gives us our column index. The right col index will be piece, I forget if it's width or height that I said. Width. Is that right? I'm going to go with it. Minus the piece dot bounding dim. Was it the height of the thing that I cared about? Minus 2 minus j. And then our I values here, so these first numbers, tell us which row you're in, trivially. Right, they count up from here. So we could, this is our 0, 0. If it's 0, it's 0. If this is 1, it's 1. So that's the easy one, this direction. Does that build? It does build. It fixed our thing. No, it blows up. Bastard. Ah, how annoying. Game Odin, line 319. Right col index plus right row index times piece width. Index is minus 1. Interesting. That's anti-clockwise that blew up. Do they both blow up? If I say go clockwise, yeah, they both blow up. Piss. And they both blow up for the same reason. It's saying on 302, as it goes to right to the output, so this is a bad value. Damn it. How do we investigate that? Start just printing out what the values are. Yeah, I think I'm gonna have to print my IJs and the outed row and the indices. That's a point. It's blowing up on 302, isn't it? Which is, oh, it's gone. Okay, do it again. Yeah, so it's the output bit. So this calculation here is wrong. Is it this value? Was I wrong? Is that actually a 1 to make it 0 indexed? No. Right. Let's not stab at it randomly. I can hear noises upstairs, so I'm just going to go and quickly check what that is. And take a short break, and then we'll go and do some more printing and a bit more debugging. So, that's something fun to look forward to. Alrighty. Got to that time, everyone starts getting up. But I think we've got a bit longer before this becomes rude. And so let's see if we can get this working. Where were we? This is wrong. I think the thing to do is print IJ right row index col index and see what we're getting. So format print line I format print line J format print line right index and format print line right row index. So which one was that? That's rotated clockwise. We do it, it blows up, we get to see our numbers. Right row index is -2. So this is the one where right col index is trivial. This is the case we're looking at. So right row index. You can see there's 0. Am I stupid? Right col index, sorry, is trivial. Because if the second number is 0, we're in 0, else 1, else 2, right? Like, that's the simple one. Means it's our right row index logic is wrong. I is 0. East height is 5. East stop bounding dim. At this point, have I updated the piece? I've not updated piece yet, have I? No. So I've updated piece is all of this stuff. Passing the active piece. So these are definitely the old bounding dimensions. Maybe that's useful to print as well. Format. Print line bounding dim is piece dot bounding dim. Run it again. Do a rotation. Width is 5, height is 3. Ah. It sounds like we might be doing the wrong one of these, right? Because that would put it out by 2. East height is a constant 5. Bounding dim width is 5. So in this case, that dimension there is 5. My right row index then is 5, minus 5, minus 2, minus that. Yeah. Yeah. Okay. Would that be bounding dim height then? Not width. So what am I looking at? Right row index. What I'm saying is as I come across here, how do I get these numbers? Piece height is 5. It is the width that factors into it though, isn't it? If I have a width here of 2, I should be going 5 minus 2. Am I thinking about this the wrong way? Can I actually just say it's the height, which put me at 2, minus 1, plus that value, and not look at the height at all? Does that do the same thing? Right, so if I come in here and I say I equals 0, width equals 5, what does that get us? Bounding dim is 5. So I go to row 5, which gives 4. It's 4. Sorry, 4. Same and go 1, 2, 3, 4, because of the values we're going to get in. These would just decrease, so I would get like that. And if width were equal to 3 instead, I equals 0 gives us 2. Let me indent. Width stays 3. I would count up to there. This would decrease and we go like that. I think that might be right. Cool. That looks better. I think it was some bad reasoning on my part. Right, can I now take that and stick it in Nya? Get the counterclockwise logic working. So let's see, what are we getting? We're in here, just check. If I go that way, I get nothing. If I go that way, I blow up. I've put that after the point I blow up, so I get nothing. So let's fix that. Let's blow up. So when j equals 1, right col index. So let's remind ourselves how this one's working. Right row index is our simple one in this case, because the right row index is just the I value. Our right col index, we're doing something similar where we're looking at the piece width, and it looks like that might be a mistake. If we instead just say, I'm getting confused now, right col index is the simple one, so it's how far to the left we are, and it's counting downward. I think this might actually be allowed to be piece got bounding dim. Is it the same or the opposite as that? I get up here. The width minus 1 minus I. Which dim do I care about? So there's the J values in here, which means it's up to the height. I just go ahead and do that. That fixed it. That looks like it's fixed it. I'm allowed off the top, so that's not a problem. Alright. I mean, that looks better. And our assertion about our point we're rotating about isn't blowing up. What is our thing? I go find where piece was defined again. Let's go find piece. Colon. Remind myself what our rotation center is. 1, 2. If I look at my piece here as it's coming in, 1, 2 is actually kind of hard to see, isn't it? Did I rotate that? 1, 2. So let's actually set it up in a way where true. I want basically 1, 2 to be one like square. That what am I saying? True. So 1, 2 means from 0, 0, I come across 1, and I want to go up 2. If I go ahead and make that all true, that all true, that all true, that will just give me a 3x5 rectangle. Yep. So then if 1, 2, the point that I want to have not move, I can put my only empty. Oh, so this is the bottom row should be all filled. This row, 1 across 2 up, so that should be all filled. Then this row, 1 across, make that empty. The bottom left corner of this should be at 1, 2. If I rotate, you can see that it doesn't move. And I can be more sure that's working. That's the bottom left of that one, so it's the bottom right of that one. It's the top right of this one, top left of that one. I should have a square that's missing. That square shouldn't move there. That's a good way of showing it. You can see we kind of move around that square. So that square just drops down smoothly. Check if I come all the way across. I come all the way across. It's all working. Until I try to do a rotation that puts it outside the grid. But we knew that. Cool. Cool. Let me just... I quite like the argument that we should have it not be too symmetric, because it makes it too easy for things to go wrong. But we can see collision boxes are working as expected. Oh, I think that might be working, boys. Ladies and gents. Check here, I can like shuffle in. Cross. Beautiful. Beautiful. Not quite complete a line, damn it. I had a piece that you can't actually play with. Can I clear a line with this piece? Nice, and that looks like it's correct. We actually never quite checked that the trickier behaviours work as expected, so that's nice. Cool. How exciting. Cool, okay. Now I'm just playing. Have I left any stuff I don't want? So I think that is an easier piece for us to do debugging with. It's useful for us to have a non-zero rotation center. And I don't think I've left any annoying stuff that I didn't want. So what is that? That is bug fix. Rotations don't displace bounding box from filled tiles. Excellent. What's left to do? Collision detection. So I think in the long run we might end up with something kind of... How complicated the collision detection needs to get, I think, depends on how it feels to play. So, like I say, I think my idea I have in my head is we'll give you this 5x5 space to design your piece, and we'll allow you, if you want, to put the rotation point disjoint from the collision, from the filled-in blocks, if that makes sense. So, you imagine I could have like a 1x3 piece that sits in the bottom left of the bounding box. I could put the rotation point at 5.5, or at 4.4, I guess, if it's 0 indexed, and rotations will jump the piece by some significant amount, either up or down and left or right. And I'm not sure at this point if it will be fun to just have it refuse to do a rotation if the place you were trying to put it is illegal, or if it's more fun to say it will attempt and then it will displace back towards your initial X position until it finds a spot that works. And if it can't find anything by the time it reaches your initial X position, it starts drawing back towards your initial Y position. Right, so it means if there's a gap that's the right size, you can slot into it perfectly, but it's more lenient in gameplay terms because if you try to do it, it will jam you back and make something that kind of sort of works and looks like what you tried. So the piece will still rotate and you'll end up in kind of a best guess position. I assume Tetris games have to deal with something like this. But because the set of pieces is predefined and the rotation coordinates aren't nuts, I guess the edge cases aren't as bad. But I want to explicitly allow you to do stupid things because I think if this is going to be fun at all, the fun will come out of that. So that's one thing. Or we could just say, if you try to do a rotation that's illegal, we beep to tell you that like we're ignoring you, and we just don't do the move. That's definitely the easier of the two to implement. So I think we implement that now. We try to get the game looking nicer and fill out more of the game, and then we come back to it if this is actually just horrible to play with. Everyone sees. Hopefully I got far enough from the mic that wasn't atrocious. Apologies if that split your eardrums. Let's look at the time. I think I can justify spending a bit more time on this. So, let's go in here and do collision detection. So what we want to say is, does the updated piece collide with anything in the grid? I think I had a look before. Update active piece position has something like this, but it has all this stuff where it has to care about whether you collide at the bottom or not. And I don't think we care. I also don't think we're going to be doing this logic in very many more places. So I'm erring on the side of dumbly copy-pasting this. And apologising to future me if that's the wrong choice, but I don't know. That just seems the right thing to do in my head. So the first thing to say is, if you don't stay within the grid, we should displace you back into the grid, or just not allow you to do the thing. I thought I have an updated pos called position in this one. Annoying. Let's just go ahead and do that. Alright, I'm going to say, if you're trying to move yourself outside the grid, just put you back into the grid. Because that is easy. And similarly, if you try to displace yourself outside the bottom of the grid, put you back in. We don't care about that. Once we've done that, we would like to say, do you overlap? So this is actually going to be updated piece. Which does not live on game stakes, it's a local. If it's not filled, we don't care. I might do some refactoring on this in a second. Y is greater than or equal to grid height, we don't care. Updated position X plus that. If updated pos equals this, if that, then we don't move you, is what this is saying. So let's go ahead and look at that. So if GS grid Y is equal to true, that do it. So if I'm over here, we get displaced that way. That feels pretty good. Right, so again, the kind of 2x2 blue square shouldn't move. Unless... Oh, okay, it's not working. Right, because that's breaking. Check you don't overlap existing pieces. Updated position dot that greater than grid width, then updated position equals the grid width minus active piece bounding dim isn't right. Okay, try that again. Rotate on this side. Can't make it break. Come up here, we rotate against this side. And it does break. There. So update position dot x plus updated piece. Greater than that. There we go. And this one that will jump us down. Sorry. Okay, I think I put it in a state that I can't get on anymore. So it's just checking that the grid boundaries work as expected. So this moves us vertically downward. And that pushed us up, right? So we come all the way down. And it pushed us up. Now let's look, if I do the same thing here, we just don't allow the rotation. Also a rotation that would be naughty than that. That does feel pretty rough, right? That if I'm near another piece, it just doesn't seem to do what I would have expected it to do. Like, it feels bad. Let me see. Yeah, so you see there, because I get it kind of like nestled right in. So in here, all rotations are bad, and it just doesn't move. Maybe that's fine. Like, maybe it only feels bad because there's no kind of like feedback to the user that we're deliberately ignoring them. Like, the piece could shake, or you could just have like a boop noise to tell you that, like, hey, we didn't just miss the input, we're actively ignoring it because it was bad. Who knows? Okay, I think for kind of a bit of a proof of concept, or I guess for a first like run at gameplay, that works for me. So I think we're going to come back and potentially fiddle with that collision detection logic, potentially significantly, depending on how things go. Because like I say, the kind of thing I think might be nicer. I'm going to draw a picture because I think it's going to be slightly hard to explain. Is that if we've got the grid, you've got like a thing here that's blocking you. Your piece is here, and the rotation that you do says, for example, I want to be here. Our current logic would just detect that overlaps, not allow it. I'm wondering if it might be nicer to say, if this happens, we start displacing you to the left, and we allow you to go until the right-hand side of your new bounding box would meet the right-hand side of your old bounding box. So in this case, we would test this position, find it doesn't work. We'd start testing positions to the left until we discovered that this actually would work, and we put you there. And if, for example, there was a piece here that was blocking that, we'd bring it across until you were in line with your original bounding box, and then start displacing you upwards until the bottom of your new bounding box touches the bottom of your old bounding box, and we discover that actually you do fit here, and we put you in. Now, that sounds like a bunch more logic that all feels kind of bug prone. And I'm not even sure that it's desirable. It might be. But we'll come back to that. None of that sounds super difficult, right? It just sounds knotty. I think like a lot of this, no single bit of it was complicated, but there's just a lot of little steps to get right, or it'll behave badly. And then there's lots of numbers to read through to check what the actual behavior should have been. I'm kind of impressed we got through it without a debugger, to be honest. I think we've done quite well in the grand scheme. I think I'm going to add the caveat. I think because this isn't my actual like full-time job, and I'm kind of squeezing it in early in the mornings and around other things. I think it's actually something I knew, but I didn't feel before doing this, that the kind of efficiency loss in not doing a thing full-time. Like, I honestly think if I was doing this full-time, I'm at where I would have been after like a week currently, right? I think it would take me 2-3 days to sort out all the Vulkan stuff, maybe a day to sort out the various kind of like buffer layers that I'm using for how I like get from game state to graphics primitives. This feels like maybe a day of fiddling, or like, you know, it's hard to do the comparisons. You have to keep reminding yourself where you're at. So I think very small steps is a good way to go. We've gotten to a thing that's playable. Let's build out the rest. So I think things that make sense to look at next would be adding a score, making the layout nicer, because currently we just plonk a little grid kind of at random. So I think if we add a score, we can start to work out then, given the screen dimensions, where does it make sense to put this grid? Where does it make sense to put the score? then that panel that has a score in can show your next piece. It starts building into like a playable game. We could then add a held piece, right? Like it all starts building out. So that could be fun. And like I said, I think the goal with this is to kind of like keep tweaking the Tetris formula a little bit. So like one thing is this rotation thing, and we're going to have like a piece designer so you can design what pieces you're going to put in. So maybe that's the first thing we aim at. Is we get a score, we get what next piece is coming up so that it looks and feels and plays like Tetris. And then we add the piece designer so we can get the actual like thing that I'm hoping is interesting. But it's nearly 9, and I think I need to go and be a grown-up and not to keep playing in my basement. So this has been fun. I will catch you on the next one, and we will keep stepping towards something that looks a bit less like a trash hobby project. But we're getting there. We are getting there. So let me say in here then. So first version of piece rotation with collision detection. And let's push all that up. And then we'll call it good. And I'll catch you on the next one.